Okay, so I am running the same setup that I did in assignment 1. So this is a Windows 11 machine. I'm running VirtualBox Ubuntu Linux. So I'm going to compile the code. I called it assign to. So if we run it now. So I decided to do FCFS and round robin. So it's going to ask us for the number of processes. I'm going to say 3. For P1 ID, I will put, let's say 4. I'm going to put random numbers, but I want them to be in not sequential order, just so that you can see how it reorders it. So the first arrival, let's say, is 5. Burst, let's say 3. P2 ID will be 2. P2 arrival, let's say 7. That would be a little bit later. P2 burst, let's say 6. P3 ID, let's say, is 8. Let's say the arrival is 1, so this will be the first one now. And then the burst, let's say, is 2. So I intentionally did this with some small numbers so that you can see what happens with round robin. The results will actually be the same. If I put a quantum of 10, you can see here, simulating FCFS, it goes P8, P4, P2, P8, P4, P2 on the round robin. Average wait time 0.33, 0.33, and average turnaround time is the same for each. So the reason why it's the same is because round robin works very similar to FCFS, where it doesn't really change anything if the processes are all done really quickly, because round robin fixes the convoy effect that happens with FCFS, where the first process or an earlier process, if it is more intensive than a later process, then it can hold up the later processes. So the way that round robin gets around this is with the quantum or time slice, where an amount of time is specified that determines whether or not that process is skipped, or, well, more accurately, the process will start working, and then at the point that it reaches the quantum, it will go to the next process, and then the same thing will happen. If it takes too long, it'll go to the next process. And when it goes to the next process, the process in this case, let's say if we're talking about P4, P4 will go to the end of the line. And the issue is, if you have something like this where it is all done very quickly, you're not going to have that convoy effect where the quantum's never going to be reached. And if it's not reached, then it's just going in that FCFS order, and it'll end up with the exact same results. So it'll actually be less efficient. It'll be more efficient to use FCFS if you know that it's going to be easier, if you know that it's going to have smaller waiting times. So if we were to run it again, but this time we say, let's just do the exact same thing actually, where we go to 4, 5, 3, 4, 5, 3, and then we have 2, 7, 6, 2, 7, 6, and then for P3, we're going to do 8, 1, but then we're going to change the burst time. We're going to do 50, and we'll have that same quantum. So what's going to happen here is, you see, it does it the same way with P8, P4, P2, P8, P4, P2 in the Gantt chart here. But then it goes P8 again, and then P8, P8, P8. And that's because if you look at P8 with the burst time of 50, it's the first one to arrive, right? So it's going to be here in this first position, but then it's not going to finish because of that larger burst time. And so it's going to kick it to the back here, to which it will then do it over and over again until it finishes. And so this can be useful at stopping the convoy effect. Ultimately, you're going to have more efficiencies if you have that convoy issue, and you're going to have less efficiencies if you don't. So in that first case, there'd be no reason to use round robin because FCFS does it just fine. So now if we look at the code, which is not here for some reason. That's why, because it was capitalized. Okay, so we have the swap function here. This just swaps the processes so that it's in order, because it assumes that it's not going to be in order by default. Sometimes it is, but it ensures that it's in order. GFCFS, so I just added the G for Gantt, so it's the Gantt chart for FCFS. This does the Gantt chart for round robin. Input processes. This just has the user inputs for everything, the process details, ID, arrival, burst. Average function just averages. This is for the average times for all of the processes. Print summary. This doesn't print the results. This actually prints the arrival and burst. It prints the user inputs that when it asks you for your user inputs, it then prints it out in the same way that was shown in the assignment specifications. Copy array. This just copies the input so that the input can be used and changed without actually needing to re-input all the values again, because the values you type in, they have to be modified, and so you have to create a copy of it so that it can keep the original information. This is just the round robin function, and then for FCFS, and then the main function down here. Okay, so one of the resources that I used that really helped me a lot was this YouTube video from KnowledgeGate CSE, and it was mainly because with round robin I was having some issues. I had a lot of experience with FCFS because my previous assignment was with it, and so I did a lot more research in FCFS, and so with round robin I needed to figure out why I kept getting so many errors with it, and so this video really helped me a lot.